discuss. Name the devices that we discussed already, semiconductor devices. We were discussing about measuring instruments, the different types. Then we started off with the third unit that is regarding different types of semiconductor devices. Two devices we discussed, no? And their characteristics and the two types of breakdown. What are the names of the devices?
PN junction and Zener diode.
PN junction and Zener diode. Okay, so we already learned what are the differences in symbolic representation between these two devices, how the characteristics are differing, and how the breakdown phenomena happens. All right, just to summarize the features of these two, how they are different. Tell some things that you remember. Some one or two points you might be remembering now how these two devices are different. Both are two terminal devices or three terminal.
Ma'am,
Two
half wave is
types.
two terminal, full wave is three terminal.
What?
Ma'am, one is two terminal, the other is three terminal.
Is it so? Very good. Then half time we were sleeping in the earlier class. PN diode and Zener diode, what are the two terminals that both the devices are having?
Cathode and anode.
Cathode and anode. So both are two terminal devices only. Okay.
Ma'am, you
Symbolic
were
wise,
asking rectifier, na?
that's why you half time sleep in class and you tell some wrong answer. Yashwant. Okay. Alright, it's okay. But be attentive. Alright. So both are two terminal devices. Okay. And how they differ? In doping wise, which is heavily doped?
Zener, ma'am.
Zener diode. Okay. So which device is capable of operating in reverse bias condition?
Zener.
Ordinary diode, if you say it is not capable of being operated in reverse bias because it will not be able to cope up with the power dissipation that happens at the junction. So you cannot operate the PN junction diode in a reverse bias. So if you want to have that reverse bias characteristics where the voltage is remaining constant with respect to the current, then you go for heavy doping to the device that will be resulting in a special type of diode that is called as Zener diode. That is why Zener diode is specifically applicable for one particular application. What is the application that it is preferably used? Zener diode is used for what application? The voltage is remaining constant during reverse bias, I told you. So what application? You have conducted one laboratory experiment also. You have drawn the characteristics. In the reverse bias, how the voltage is present? It is constant. One straight line you are having. So it is preferably meant for what application? Voltage regulator. So what is voltage regulator? The voltage remains constant regardless of whatever may be the changes in the line side or the load side. The voltage will be always 5 volt means 5 volt, 6 volt means 6 volt. Okay, it will not change. That is the meaning of voltage regulator. And what devices are preferably meant for voltage regulator application? Zener diodes. Okay. And what type of breakdown occurs in both these? Two types of breakdown I explained. In PN, what breakdown occurs, and in Zener, what breakdown occurs? One breakdown is avalanche breakdown, second breakdown is Zener breakdown. So which breakdown occurs in what device? If you are not going to give me answer, I will handpick somebody to give me the answer from them. Okay. If not, if they are not giving answer, I will give them punishment. If it is okay with your side, better volunteer in giving answers. Okay. I will handpick somebody to give me answer. Nagasani will tell me what breakdown occurs in what device. Nagasani, Nagasani is present. Nagasani, Gaurav Soni, Gaurav Soni, Akshit, Sai Akshit, Niraj. If somebody is not giving me the answer or not even trying, they will get punishment. If you are not giving response from your side, it means that you are not here. You are doing something else. That goes for Nagasani, Gaurav Soni, Akshit, Niraj. Nobody is here. Ram Charan,
Yes, ma'am.
who is telling yes, ma'am?
Ramcharan, ma'am.
Ram Charan, tell me what type of breakdown occurs in what device? There are two types of breakdown. One is avalanche breakdown and the other one is linear breakdown. So which breakdown happens in what device?
Not bad.
You don't know?
Same devices.
Avalanche, PN diode and Zener diode. Yes, yes, tell.
Ma'am, avalanche occurs in Zener diode, but ma'am,
Avalanche occurs in Zener diode. Huh? Very good. Avalanche breakdown means it is because of the thermally generated carriers going and hitting the covalent bonds, thereby releasing more and more free mobile carriers. And the action will happen in a cumulative manner in terms of a chain reaction. That is why the breakdown happens in a PN junction diode. Okay, that is not a favorable one. So avalanche breakdown happens in a PN diode. But if you see to the Zener diode, because of the heavy doping that you are having, the electric field itself will be strong enough to directly rupture the covalent bond. Here you are not going to use the thermally generated carriers to go hit the covalent bond. Directly the strong electric field that is present is directly going and rupturing the covalent bond. That is why it is able to produce the breakdown at an earlier voltage, which is called as Zener breakdown voltage. And when this breakdown happens, the voltage will be always remaining constant regardless of what may be the current. So Zener breakdown, as the name suggests, it is specially meant for a Zener diode. Okay, so this means that half class is not attentive to whatever topics I am teaching you. Here afterwards, be ready for me to question you people. Single. So next we are going to discuss what are the various applications that you are having for a PN junction diode. So what are the various applications? Name some. I've already told you all these things in earlier classes and lab classes, and I told you I won't be teaching all these topics in an elaborate manner. So what are the applications for PN junction diode that you are having? One application is rectification. Under this you will be studying half wave rectification and full wave rectification. Next you will be having wave shapers. What are the two wave shaping circuits? All these things we have discussed in lab class, I think so. So what are the two different wave shapers that you are having? Wave shapers. Again I will point out somebody. Okay, today I am going to mark this Nagasani. This whoever is not answering my questions, they will be marked absent as punishment. You cannot question me unnecessarily. Okay, Akshit, Gaurav Soni, all of them I'm going to mark you absent. Okay, don't ever try to question me. Okay, and claim your attendance from my side. Prabhas, tell me what are wave shapers and what are the different types of wave shapers? Prabhas, Balamaniganda, Jay Praveen, Veeravardhan. Again, I'm telling you, whoever is not even trying to respond from your side, they will be marked absent, and you cannot claim your attendance from my side. You cannot give an excuse. Tell me, Balamaniganda, what are the wave shaper circuits that you have studied in your laboratory class? Laboratory, there is an experiment called wave shapers. Under that, what are the circuits that you are trying? Jay Praveen, Mita
Ma'am,
Yashwant,
can you hear me?
Mayank.
Ma'am,
What? Tell me, Jay Praveen, what are the two wave shapers that you tried in your lab class? Balamaniganda, you should try to be
Fast.
attentive in class.
Hello, ma'am. My mic is
Tell.
working. No,
And type in the chat box. Always my chat box is open for you people to chat. Again, I'm
low pass
telling you,
RL circuit.
low pass, high pass are okay. Other way of naming is low pass, high pass, but you cannot say low pass, high pass. You have to define it common, no clipper and clumper. You people are all are having brain to remember things, or you don't have brain to remember things. You just take in and you forget everything. Is that so? Don't feel bad that I don't know what to tell. Don't you have at least 10% of memory capacity for your brain? I am not asking detailed things. Only the topic alone I am asking you. That alone you cannot remember. That you are doing in lab. I don't know what you people are doing in
Hello.
lab.
Ma'am, half wave rectifier and clippers. My mic wasn't working.
Okay, so these are the wave shapers, and why are they called as wave shapers? These are the
Because
various
they change the shape
applications.
of because they change the shape of wave when giving output.
Okay, so rectification, half wave rectification, full wave rectifier. Then wave shapers, they can be of two categories,
Clippers
clippers
and
and
clamp.
clampers. And under clippers, you are having two categories, positive and negative,
Positive and
and
negative.
then biased and unbiased.
Unbiased.
And they are called as wave shapers because the input signal that you are giving is a sinusoidal one, but if you refer to the output side, you are having a clipped one or a rectified waveform. So whichever waveform you want to desire at the output end, that is being obtained by properly shaping up the input voltage. That is why they are called as wave shapers. And this wave shaping, it happens by the combination of R, C, and L and one diode switching elements. By combining all these things only, you are able to do that wave shaping. So all these will be coming under the applications of the PN junction diode. Now, first thing that you are going to discuss about is rectifier. You know what is a rectifier, that you must have studied 100 times, and you must have heard out the definition 100 times. So what is the process of rectification?
It converts AC to DC.
AC to DC conversion. Okay, so the input waveform here, as you can observe, that is of what nature?
Sinusoidal.
Sinusoidal. So AC is the input, and if you refer to the output, what is the output that you are getting?
Only in the positive side.
Yes, this is DC, but it is pure DC or pulsating DC?
Pulsating DC.
It is a pulsating DC. So whatever the rectifier does, it is converting AC to DC. That means it converts the input sinusoidal waveform to a pulsating DC. That is the work of a rectification. If you include a filter at the output side, you will be able to get almost equivalent to pure
Yeah.
DC. Okay. So this is one application for the PN junction diode. The other applications are clippers and clampers that we are going to discuss in today's class. Now under rectification, so many categories are there. What are the different types of rectifiers that you are having? HWR, that is half wave rectifier. Full wave rectifier is of two types. One is center tapped and the other one is bridge. Okay, so two types of full wave rectification is possible. One is center tap rectifier and the other one is bridge rectifier. So both are going to be discussed today. First, let us discuss half wave rectifier. Now the circuit resembles your half wave rectifier. So how many switching devices or diodes are here? This is your PN junction diode. You are using PN
One.
junction diode.
One.
Number 1 is used here. The input that you are giving is your sinusoidal input, and the output side you are going to get a pulsating DC. And in order to achieve this, you are using a step down transformer in between. 230 volt will be stepped down to 6 volt or 8 volt, then it will be rectified to DC. That is actually going to happen, and RL is representing your load across which you want the output. Now half wave rectifier, why it is called so is because now if you are assuming that the input is going through a positive half. Okay, when the input is positive, then here you will be having positive and here you will be having negative. So the diode will be forward biased or negative biased. You know the forward bias action. If this is the diode, this is your anode, this is your cathode. Anode is positive with respect to cathode, which is negative. So if you are giving such a biasing condition, then it will be forward bias or reverse bias? Forward bias. Then the diode will be in conduction state or no conduction state?
Conduction.
Conduction. Okay, conduction. That means the switch will be closed or it will be opened? Closed. Okay, so if this is the case, then this will be closed circuit. So whatever may be the input that you are giving, same input you will be observing across the load. Okay, so you are having a load output. Alright. Now next case, assume here you are having a negative half. Right. When the input is negative here the anode will be becoming negative and the cathode will be becoming positive. Then this type of biasing is called as what? Here you are having anode, here you are having cathode, but you are negative and here positive. So this biasing condition is called as what?
Reverse.
A reverse bias condition. Okay. When the diode is reverse bias, will the device conduct or not conduct?
Not conduct.
It will not conduct. Okay. The device will not conduct. And the switch will be now open or closed?
Open.
Open.
Open. Okay, the switch will be open. The diode will be open. So if this is open, in this circuit, the path here will be open. Okay, here it will be open circuit. So the input and the output side will be connected or not connected if the diode is open. Not connected. So will there be any output or no output in this period?
Output.
No output. So output is 0. Okay. So this is how the half wave rectifier, the output is produced only for positive half cycles alone. That is why the name is what? What is the name of this type of
Half wave rectifier.
Half wave rectification. Now if you want to obtain the output during both cycles like this, still it is a pulsating DC only. So you want outputs to be obtained at both the cycles. So that process of rectification will be called as what rectification?
Full wave rectification.
Full wave rectification. And full wave rectification is possible in two ways. One is center tapped and the other one is bridge rectifier. So this arrangement is your center tapped one, because here you are observing there is a center tapping. By adjusting this tapping, you will be able to vary the output voltage. So this is full wave rectification using center tapping. And how many diodes are used here?
2 diodes.
2 diodes. So this is also coming under one of the application of PN junction diode, full wave rectification. As usual, you are having a load across which you are going to tap the output. Now again, as usual, you are going to give the input. Okay. Now when the input is going through positive half cycle, which diode will be here positive?
Upper diode.
Upper diode. Here it will be positive, negative. Here it will be negative, positive. Okay. So comparing D1 and D2, which will be in forward bias condition?
Upper one forward, lower one reverse.
So this switch will be closed, but this will be open. Okay. So the circuit will be closed and it will be passing the output here. Alright. Consider next case when the input is going through a negative half. Then in that case it will be negative here, here it will be positive, and here it will be positive, and here it will be negative. So which diode will be conducting here?
Below one, down one.
Yes, this will be closed, but this will be open circuit. So again, via this device you will be able to pass the current, or whatever may be the input here, that will be conducted at the output side. Okay. So this is how full wave rectification happens. Okay. So that is because of the center tapped transformer. Another way of, suppose if you use a center tap transformer, there is a drawback here. Okay. The arrangement will be very bulky and it will be expensive if you are using a center tapping. Okay, so if you want to eliminate this center tapping and if you want to replace the center tap transformer by means of a two winding transformer itself, then you can go for a bridge rectifier. Okay, you can go for a bridge rectifier arrangement. The reason for going for the bridge rectifier arrangement is to avoid the use of center tapping, which is usually bulky and expensive. So this is your full wave rectifier with no center tapping with only two winding transformer. The name is bridge rectifier. So how many diodes are you having in the bridge? Bridge usually has 4 ohms. So accordingly you will be having how many diodes?
4 diodes.
4 diodes. So here how the conduction will happen?
And can you repeat the question? Voice broke.
Okay, so this is your full wave rectifier with no center tapping transformer. Okay, no center tapping transformer. As you can see here, there is no center tapping, only an ordinary two winding transformer is present. So this is why people go for bridge rectifier. Because if you are using a center tapping here, it will become a bulky arrangement. It will become an expensive arrangement because of the number of turns of inductor that you are using at the secondary side. So people don't want to use a center tapping. So instead of a center tapping, if you want to go for a single transformer, two winding transformer, then the option is bridge rectifier. And as you can see, this is your bridge, which is having 4 arms. So how many diodes are probably present? Each arm has one diode. So how many diodes are present in a bridge rectifier?
4.
4 diodes. So diagonally opposite diodes will be put into conduction here.
Ma'am,
Okay,
your
diagonally
voice is
opposite.
breaking a lot. Is it only my side or everyone is facing problem?
You ask your friends. Is my voice audible to everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
There is your answer. Okay. So suppose again as usual the input is your sinusoidal AC. Suppose if it is going through a positive half cycle, then which diode combination will diagonally act to give the output voltage, that is positive half cycle here. If it is passing through the positive change, positive transition, then this diode it will be positive negative. Okay, and it will be closing with the D3. So D1 and D3 will be in action. So this part is because of D1, D3 diodes. Okay, and they will be closed and it will be delivering the input to the output. Now if it is going through a negative transition, now these two diodes will not conduct. Okay, these two diodes will not conduct. But on the other hand, you will be having D2 and D4 to be conducting. So in the next case, the action will be because of the diagonally opposite diodes D2 and D4. Okay, so this is how full wave rectification happens because of what type of rectification? What type of FWR is this?
It's trap.
Full wave
What
rectifier.
type of full wave rectifier? So how the action happens here?
D1 and D3 at a time and D4 and D2 at a time. When
Yes,
for
during the
first
positive transition of the input cycle, the diagonally opposite diodes D1 and D3 will be in conduction. They will be closing. There will be forward bias and they will be connecting the input to the output. Second case, when the input is going through a negative transition, these D1 and D3 will be put into cutoff. It will be open. But the remaining two diagonally opposite diodes will come into conduction and they will be connecting the input to the output, but in the reverse side. Alright. So this is how the action happens for bridge full wave rectifier. So this finishes of one application of PN junction diode. So what are the other applications that you are going to discuss about? We are discussing applications of PN junction diode. One is rectification that we have already discussed. What are the remaining applications that you are having? Wave shapers, clippers and clampers, But before discussing that, we need to discuss types of filters also. So suppose if in the same circuit, if you see, so this is your half wave rectifier, but here as shown in this diagram, are you having any filter at the output side?
No, ma'am.
No filter. That is why you are getting only a pulsating DC. Okay, suppose if you assume, okay, I am connecting one capacitor here, which is a filter, and then comes my load. Okay, so here in terms of a filter, I have added one capacitor. So I am having a capacitive filter. So when I am adding a filter here, then what will be the change that will happen? Earlier, my output was pulsating DC. Now I want to convert it into almost an unidirectional DC. So that will be possible with the help of this inclusion of the concept that is called as filtering. So if this is the case, the output that you will be getting will be just the envelope. Okay, like this. Again. Okay, so this red color waveform and the blue, this waveform, this is a pulsating DC. If you compare this, the ripples are almost less when you are seeing the filtered output. Yes or no?
Yes, ma'am.
So this is how you are converting a pulsating DC into an almost unidirectional DC. You are trying to bring the waveform to a pure DC almost, which is devoid of any ripples. Okay, so that is the use of a filter concept here, and there are different types of filters that is possible. So the types of filters we will be discussing here. Same here also. In full wave rectifier also, here are you having any filter here? No. Suppose if you are using a capacitor here, okay, instead of a pulsating DC, here you will be able to get a ripple free DC. Okay, so this is the advantage of having a filter at the output side. So what are the different types of filters that you are having? There is a list, some important type of filters it is listing here. So what are the different types of filters that you are having? Come on, four number of list is
Induction
present.
capacitor LC or L section
You are
CLC
having
or
an inductor filter, capacitor filter, inductor capacitor filter, or capacitor inductor capacitor filter. Okay, capacitor inductor means it will be present like this. So the shape is representing what Greek letter?
Pi.
pi.
Pi. That's why it is called as pi filter. Suppose if it is L and C means it will be resembling L shape. Okay, that is why it is called as an L section filter. So the four different types of filters are what? Inductor filter, capacitor filter, LC filter, and CLC or pi type of filter. Now, if you are going for a capacitor filter, you assume, okay, you know it is a capacitance. So, what is the special property of a capacitance? When it comes to giving AC and DC, what happens to the capacitance? What component will it allow? There is a special feature of a capacitor, isn't it?
It will
When there
take
is a,
it will
when
take
there is a
the
capacitive element here, it will pass AC or DC. Which component will it will pass and which component it will block?
it will pass DC and block AC.
Yes, it will.
Passes through
It
AC.
will. It will be passing AC alone, and it will be blocking DC. That is a special property of a component that is called as a capacitive component. Okay, this salient feature of capacitance will be taken into account for filtering. So again, I'm telling you, if you are having a capacitance here, it has a special property of allowing only AC component, while it will be blocking the DC component. Okay, now we are going to add that at the output side. Okay, so this is my load component, and this is my C filter. So here I am having a full wave rectified output like this. Okay, so this is my pulsating DC. All right. Now at the output side, I want to have a ripple free DC like this. Okay, this side I am going to have a ripple free DC, almost unidirectional DC. For that purpose only, I am adding what type of filter here?
Capacitive filter.
Capacitive.
Capacitive filter.
Capacitor filter.
Capacitive filter. Now, what will happen here, as you already told me, it is going to block the DC and it is going to allow only AC component. Okay, so whatever may be the AC component here, there must be some ripple here, that is your AC component. That AC component will be charged here in the capacitor and it is connected to the ground. So whatever may be the AC component that it is having, it will be shorted to the ground. Okay, it's shorting AC to the ground. Okay, so it is taking up the AC quantity, that is ripple quantity, and it will be shorting that AC quantity and it will be delivering it to the ground. So once the AC component is thus eliminated, what will be the resultant remaining output that you are having?
It will be ripple free DC.
Yes, it will be ripple free DC. Understood how the capacitive filter acts? Whenever you
Yes,
are
ma'am.
adding this capacitor filter at the output side, it's having a special property of allowing AC component alone and blocking DC. So because of this special property, whatever may be this will be actually AC plus DC. That is ripple plus DC. So whatever may be the ripple, that will be charged in this capacitor. So AC component, ripple component will be eliminated and the remaining component will be delivered to the load. So that is how capacitor type of filter acts, and as a resultant of which you will be able to get a pure ripple free DC. This is your ripple free DC, and this point is where the diode, that is full wave rectifier diodes, cut in. It will start to conduct. Okay, and when the diode starts to conduct, the capacitor will be charging to the maximum value. Alright, then at this point it reaches the maximum value, after which there will be a slow discharging of the capacitor. Okay, there will be a slow discharging of the capacitor, very slow, and it will be delivered to RL. So the amount of time that the capacitor is holding that charge, it will be equivalent to the diode conduction period. Okay, and at this point the diode is said to be cut out. Okay, once the diode is cut out, it will start to discharge very slowly. Okay, so if you see to the waveform, this portion will be your charging period, where the capacitor is charging to about maximum value from the diode cut in, and after which this period is called as your discharging period. That happens very slow comparatively to the charging phenomena. Okay, so discharging will be very slow, as that will be happening after the diode cuts out. Okay, this
Ma'am, I
what
have a doubt. Ma'am, why does the diode cut out at the maximum point instead of the
so
end
that
of the
is
first?
because of the rectification process, no? That positive half cycle, negative half cycle transition happens now.
Ma'am, but the ma'am, the 1 and 3 diode cuts out. Ma'am, because in the full
First set of the diodes, it's go the rectification output here. Here it reaches maximum. Okay, all right. But after this, what happens to the conduction process? It achieves maximum. After which, still it goes on increasing or it is reducing to 0 point.
reducing.
That's why.
Ma'am,
Okay.
but until 0 it's still conducting only, no?
But it is slight conduction only, no. It is dropping its conduction, yes or no?
Yes, ma'am.
That's why it is called as cutout point.
Okay, ma'am.
Okay. Here you can see here. The diode stops conducting when the transformer voltage becomes less than the diode voltage. Okay, that voltage is called as your cutout voltage. After that, it will not rise beyond the VM value. It is going to drop down only. Okay. Next, only capacitor filter is included, I think so. So we'll skip the other types of filter. Inductor filter, if you assume, means it will work in an opposite manner. When a capacitor filter is having the property of allowing AC and blocking DC, what will the inductor do? Inductor is quite opposite behaving, no? So what will it do? Again, I'm telling you, capacitor is allowing AC and it will be blocking DC. What about the inductor? It behaves in quite opposite version. So how will it behave?
Block AC and conduct DC.
Allowing DC and block
Block AC and it will allow DC. That
allowing
way,
DC.
if you are connecting inductor means it will filter out. Okay, those things are not included in your syllabus, I think so. So we'll skip it. Next wave shaper is regarding clipping. And as you can see in the circuit, we are having a combination of what to have a clipper. There is a diode here again, so it comes under the application of PN junction diode. Along with the diode, you are having one wave shaper. What is the wave shaper that you are having? What is this component?
Resistance.
Resistor. So whenever you are adding a resistor, capacitor elements into the circuit, it will wave shape. Okay. So you are going to use the PN junction diode and the resistance to do clipping phenomena. You know what is a clipping. Suppose if I have an input sinusoidal, I want the positive portions to be clipped off or negative portions to be clipped off, or if I want to include DC in addition to the AC. So like this, I want to reshape the waveform. Okay, so all this is possible by clipping or clamping that we are going to discuss now. That is why they are called as wave shapers. And what are the applications where it is being used here? Where are you going to need this wave shaping or clipping?
In
Come on,
any
there are some applications. Radars,
Radar.
digital computers, radio receiver, television receiver. Yes, in all these applications, you might need a clipper circuit. So you will be using clippers. And how can you classify clipper? We can classify clipper into what different ways? We can either classify it as positive and negative clipper and biased and unbiased clipper. Okay, so this diagram shows you what type of clipper?
Positive clip.
Positive.
Positive clipper. So what portion of the input waveform will it clip?
Positive.
Positive. So if you refer to this waveform, this is your input waveform that is having both positive and negative off cycle. But if you see to the output, only the negative portions are retained. There are no positive off cycles. That is why it is called as a positive clipper. Okay, positive portions of the input waveform are clipped, or if positive portions greater than V reference is clipped. Okay, remember this point. Portions of input greater than V reference clipped. Then that type of clipper is called as what clipper?
Positive.
What is the name of the positive clipper? Greater than V reference point. Okay. Suppose if it is less than V reference means what type of clipper?
Negative.
Negative clipper. Simple. Okay. Suppose if you are keeping V reference as 0. Okay, this is your V reference that is 0. And above portions greater than V reference is clipped. So this is your positive clipper. Suppose if you are giving V reference is 1 or 2 volt, that 1 or 2 volt will come here, 1 volt. The above portions alone will be clipped. If you draw the waveform, it will be coming like this. Okay, that type of waveform, that type of clipper is called as what clipper? That will be called as biased positive clipper. Understood the difference between unbiased and biased clipper? Come on, have people understood the biasing concept in a clipping
Yes, ma'am.
application? Okay, so here it is a unbiased clipper only because V reference here is set to 0. There is no reference voltage given here. So now how the action happens is the question. So again you assume the positive half cycle is given. So here it will be positive, here it will be negative. Okay, so the diode will be forward biased or reverse biased.
Forward bias.
Forward biased. So diode will be conducting or not conducting?
Conducting.
Conducting. The circuit will be closed or not closed?
Closed.
Closed. So it will be shorted or opened. This will be
Shorted.
short. Okay, so this will be short. So whenever you are having short circuit condition, what will happen to the voltage? Will there be any voltage?
Yes, ma'am.
Yes, sir.
No,
Very good.
along this there will be zero
You
voltage.
know VOC, ISC. So short circuit means what will be not present? Only current will be there, shorting
Yes,
condition.
ma'am. Yes, ma'am. Yes,
So
ma'am.
what will happen to the voltage?
Zero voltage on both sides.
Zero voltage. That is why at this portion are you having any output?
No, ma'am.
Are you seeing any output? So zero. Okay, no output. Second case, when the waveform is undergoing negative half cycle, then here it will become negative, here it will become positive. So what will happen to the diode?
Reverse bias.
Reverse bias. So the circuit will be open or it will be closed?
Open.
It will be open.
Open. Okay, so there will be no diode conduction. That whole branch is open now. Okay, so whatever may be the input, this is your input that will be delivered to the output side. So will you be able to get waveform or not?
Yes, ma'am. We'll get negative
Yes, here
waveform.
will be V naught is equal to Vn. Okay, so this is what is called as, what is the name of the clipper?
Negative clipper.
This is negative clipper, very
Sorry,
good.
positive clipper.
Positive clipper. Okay, now I want negative clipping. So what can I do? One simple change only I can do. I want to change the circuit or transform the circuit into a negative clipper. So what will I do?
Ma'am,
Ma'am, reverse the diode.
Yes, this is positive clipper. Just if I am reversing the diode. Okay. Then what will happen during positive half cycle? This
It
will
will
be
be in
positive,
reverse
it will
bias.
be negative. Okay. So reverse bias. All right. So in if it is reverse bias means this circuit branch will
Open.
be open. So whatever may be the output that will be delivered and output you will be getting.
Vn equal to
But
VH.
during negative half cycle, what will happen? Negative half cycle,
It will be shorted. Hence, no
shorted. It
voltage
will be
will be there.
shorted. So here there will be no output. So you will be getting only positive
Zero.
portions alone, while these portions will not be there. So that type of clipper is called as what clipper? Negative
Negative clipper.
clipper. Okay, right. So this is a circuit for negative clipper. You understood the difference between positive and negative clipper? Huh?
Yes, ma'am.
Okay, next we will move on to biased clipper. So this circuit, I wanted to change it to a biased clipper, biased positive clipper. So what addition have I made here? Tell me what extra thing has been
I
added up
added
here?
a voltage.
A voltage. Okay, so if you do so, earlier this voltage was not there. So V reference was assumed to be equal to 0. Now if you are varying the voltage, it will be set to some value, maybe 1 volt or 2 volt or 3 volt, whichever may be your requirement. Okay, so that is your V reference here. Okay, let us assume this is 3 volt positive. Okay, that way it will be becoming a biased clipper. So if it is biased means the diode will be conducting only when that voltage value, input voltage, as long as it is less than V reference, it will conduct. Okay, other times it will not conduct. Okay, this is a portion where it is greater than V reference that is being clipped, and under this portion it will conduct. Okay, diode will be connecting the input to the output, or I think diode will be open. Okay, so input will be connected to the output side and the diode will be open. Okay, and during this portion you are able to get the output. Okay, that is the difference between biased and unbiased clipper. So whatever portions are greater than V reference, those portions will be clipped. That type of clipper is called as positive clipper. Under that V reference only, the input will be connected to the output. Okay, so this is positive biasing. So negative biasing is also possible if you interchange this VR. Here you are having what type of circuit? What type of circuit is this? The title is also given now here.
It is a
Negative
negative.
bias.
Negative
Bias.
clipper. So originally this, without this V reference, you will be having this circuit as a negative clipper. Now one extra addition you have made here, you have added a negative VRPS minus here and plus here. If you give such a connection, that will be becoming a biasing negative clipper, and you refer to the waveform. Just by adjusting this V reference, let us set a V reference value, let this be minus 3 volt. Okay, and I want it to act like a negative clipper, so whatever portions that are negative, which is less than V reference, which are less than V reference means this portion or this portion, upper portion or lower portion.
Upper, ma'am.
Less than V reference, I am telling how it will be upper. Less than V
Less
reference. So
than down.
this is my V reference.
Yes,
So
ma'am.
less than V reference is under portion. So under portion will be clipped. So this is a negative clipper or positive clipper?
Negative, ma'am.
Negative clipper. So if it is V reference made equal to 0 means this portion will be clipped. But here V reference is given minus 3 volt. So below that portion only will be clipped. Okay. So this is your V reference that is said to be minus 3 volts. So less than V reference portions are clipped. So this is becoming a negative biased clipper. Okay, above V reference only the diode will be connecting the input to output. Okay, understood? What is clipping?
Yes, ma'am.
What is clipping generally? Tell me again.
Is the removal of a part of the waveform.
Which are
Yes,
below.
partial portion of the waveform is clipped. Portions greater than V reference is clipped means what type of clipper?
Positive.
Biased clipper.
Positive. Portions less than V reference is clipped means negative clipper. If V reference you are putting it to 0 means that will be biased clipper or unbiased clipper?
Unbiased clipper.
Unbiased. If you are setting a V reference to some value means it will be a biased clipper. Okay. Now one more application that is called as your clamper. Okay. Clamper. Clamper means it is also called as a DC restorer. Okay, that means it will add DC to the input. Okay, if you want to add some V reference value that is DC to the existing input, then that type of application is called as what? What is the name of this application? DC restorer, a DC adder. What is the application called as?
Temper.
Clamper. Okay, clamper. The other names are called as what? DC restorer, DC inserter. Okay, DC inserter, DC restorer, all are one and the same. Clamper, all are one and the same. Here also you are having positive clamper, negative clamper, and you can add RPS here also. All the versions are possible. Now if you see, what is the combination that you are using here? For clipper you are using a combination of diode and resistor. But here you are using a diode and a capacitor. Okay, and this circuit is called as a negative clamper. What happens between the input and the output? You observe the waveform and tell me. And what are the applications that you are having? Some applications are also specified, no? Where you are going to use a clamper. So what are the various applications that are listed out here?
Television.
You are having a television receiver, okay,
Yeah.
where you will be adding some DC reference signal to the video signal. In these applications you need a clamping network. For that purpose only you are learning out the circuit. And if you refer to the input and waveform, what happens here?
Amplitude, ma'am.
Here this input is like this. Here you are having V reference. Okay. Now this is your 0 V reference. What happens to the waveform? Here this above the V reference you are having positive half cycle, here you are having negative half cycle. Now the entire waveform is shifted or not shifted in the output side?
Shifted, ma'am.
It's shifted and
Shifted.
every point is reduced by 2 volt.
Now every point is reduced means this is a peak clamper actually. Okay, so here you are having V minus V, but here what is the amplitude that you are having? 2 Vm. Okay, so what happens here? The waveform gets shifted to the negative side or a positive side?
Negative.
Negative side. So the entire waveform peak to peak value is shifted below V reference or above V reference?
Below V
Below
reference.
V.
Below V reference. So this will be becoming a negative clamper or a positive clamper? Negative clamper or positive clamper?
Negative, ma'am.
Negative clamp.
Negative. Negative clamper because the entire waveform is shifted below. Okay, below V reference. Alright, you can see this is your V reference which is 0 actually. So this is an unbiased one. Okay, you can make it biased also. If you are making it biased means if you are setting a V reference here, some V reference, let us consider this is your 0 point V reference or 0 time, and here you are setting V reference equal to 2 volt. This is your DC that you are adding to the existing AC. That's why it is called as a DC restorer or DC inserter. Okay, that way it will be becoming a biased negative clamper. That is also possible. So you understood the difference between an unbiased negative clamper and biased negative clamper?
Yes, ma'am.
Yes, ma'am.
Okay. Now how that waveform is produced is because there will be two actions. Okay, one is when a V reference is given, one is when AC is given. Both these effects will be superimposed as a resultant of which you will be able to add the DC and AC. Okay, and what theory is given here? Tell me, during the positive half cycle, the diode conducts. It will be acting like a short circuit. The capacitor will be charging to V volts. During this interval, the output which is taken across short circuit will be V naught is equal to 0 volt. Okay. Next case, as we have seen in the earlier case, during the negative half cycle, the diode is open, and these two will be summed up. Okay, so minus V minus V minus V naught they tell. So this is how V naught is equal to the twice the value minus 2 volt. Okay, suppose if we are adding V reference to this case means plus 2 volt or plus 3 volt, whatever value of V reference that you are setting will be added up. But here at this point V reference is equal to 0. Okay, that is what they are telling. With the circuit will tell. So suppose if the input is undergoing a positive transition means as we have discussed in the clipper case, this diode will be, this capacitor will be charged to V volt. Okay, and at the same time diode will be forward biased. So it will be closed, it will be acting like a short circuit, but V naught will be equivalent to 0. Okay, second case when it is undergoing a negative half cycle, the opposite action will happen here. Okay, this diode will become open. Alright, the entire waveform will be given to R. Alright, that is how V minus V plus V naught they are telling. So V naught is equal to minus 2 V volt. The when the cycle is undergoing negative, that negative half transition plus the already stored charge in the capacitor both will be added up. Okay, so this process is called as what process? What is the name of this circuit?
Negative.
Clamper.
Clamper. So what will a clamper do?
Shift the V.
Shift the
Is it will shift the waveform, entire waveform below or above reference. If it is shifted above reference means it will be a positive clamper. If it is shifted below reference means it will be a negative clamper. Suppose if V reference is equal to 0 means it will be an unbiased clamper. If you are giving some value, if you are giving a RPS here, and if you are setting V reference equal to 2 or 3, whichever may be the case, then it will be becoming a biased negative clamper. Okay, here it will be negative and here it will be positive. Right? How it happens is during positive when this diode is in conduction state, this will be charging minus V. Next case it will be retaining, I mean discharging, plus it will be charging again. Okay, so for 2 times V you will be getting at the output. Suppose if you are adding one extra V reference to it, then to the output voltage you will be having that extra V reference. Okay. So this is a circuit of a positive clamper. In order to obtain the positive clamper, just you are doing what with the diode? Just you are doing what with the diode if you want to have a positive clamper?
Sir, diode.
You reverse the direction or connection of the diode, you will be able to get a positive clamper. This is an unbiased positive clamper or a biased positive clamper?
Unbiased. Unbiased.
Unbiased positive clamper. Same action will happen but in the reverse manner to that of the negative clamper. Okay. The capacitor which will be charged to V, the next cycle, it will be holding the charge, so the total swing will become twice. Okay. So here as you can see between the input and the output, what happens to the output waveform? This is my V reference here. This is my T, ground value, V reference. So greater than V reference, the waveform is shifted or below?
Above.
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 Okay. So this will be becoming a positive peak clamper. Why it is a peak clamper is because the entire peak is shifted. Okay. Suppose if partial peak is shifted means that will be not be called as a peak clamper. Okay. That will be a biased clipper. If you wanted to change it to a biased clipper means you add one RPS here. That's all. Okay. It will become now biased. Sorry, not clipper, clamper. Okay. So now finally, conclusion, what are the different applications of diode? Applications of PN diode, what are they?
Flipper, clamper, rectifier,
Rectifier, what are the categories that you are
Full
having?
wave.
Half
Full
wave,
wave.
half-wave, full
full
wave,
wave.
bridge,
What are the
center.
two types? Bridge and center tap.
Bridge type.
And these circuits may work with the filter and without filter. So what are the different types of filters that you are having?
Flipper, clamper,
Inductor, capacitor,
Filter. Capacitor, inductor, CLC,
capacitor,
LC.
inductor, L, C, pi.
And then what are the other applications that you are having? Clipper. Under clipper, what are the categories that you will be having?
Positive, negative,
positive,
biased.
negative, bias.
Positive, negative, biased. Okay. Under clamper, what will you have?
Positive,
Positive,
negative, and
negative,
Positive,
biased.
negative.
bias.
Okay. That's all. With this, we'll wind up the class. Okay. Next class, we will discuss another device that is BJT characteristics. We'll discuss. Okay. All right. All can disperse.
Bye, ma'am. Thank you,
Okay,
ma'am.
ma. Okay.
Thank you, ma'am.
Thank you,
Okay,
ma'am.
ma.
Thank you.